Hero of Alexandria was a 1st century mathematician. Here he is over here. Stately looking guy. And among other things, he came up with what's called Heron's formula. Or maybe we should say he discovered Heron's formula, which is a formula that you can use to find the area of a triangle if you have all 3 sides. So Heron's formula uses the semi-perimeter of a triangle, which is just half the perimeter. So if we have a triangle down here, we have sides A, B, and C, then the semi-perimeter would be A plus B plus C divided by 2. And that's the semi-perimeter. Then, so if we have the semi-perimeter, the area is the square root of the semi-perimeter times the semi-perimeter minus side A times the semi-perimeter minus side B times the semi-perimeter minus side C. And that is Heron's formula for finding the area of a triangle. Let's do some examples. So here's our example. It's in 2 parts. The first part, we're going to find the area of a triangle that has sides 5, 6, and 7 using Heron's formula. So here's 5, 6, and 7 for this triangle. Now, Heron's formula, we just talked about it. Heron's formula, the area is the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. So let's go ahead and find the semi-perimeter. If I can get the right color. The semi-perimeter is 5 plus 6 plus 7 divided by 2, which is 18 divided by 2. 18 divided by 2. Or 9. It's nice that it's a whole number, because sometimes it's not. But here it is. So then, if we're talking about the area equals the square root of, let's see if we get 2 colors, 9 times 9 minus, well, let's say A is 7. Why not? Well, we'll say A is 5. 9 minus 5. 9 minus 6. And 9 minus 7. Which is the square root of 9 times 4 times 3 times 2. Okay, 4 times 3 is 12. What if we do this? 4 times 3 is 12. And 12 times 2 is 24. So then 9 times 24. 9 times 24, I think that's 216. I feel good about that. 216. 9 times 20 is 180. 9 times 4 is 36. So then that 9 times 24 is 216. Okay? And the square root of 216, well, maybe we could have simplified a little bit better over here. If we break that down, well, I think 9 is good. 9 and 4 and, well, okay, let's back up just a second before I get ahead of myself. So we want to simplify this, right? Because the area of the triangle, it's not nice to have it as the square root of 216. So let's get a simplified radical, right? The reason why I hesitate is because we probably should have just left it as 9 times 4 times 3 times 2 and then broken it down. So let's go ahead and break it back into 9 times 4 times 3 times 2. Now remember, when we simplify radicals, we just take the square root of each of these individual pieces. So the square root of 9 is 3. That goes outside. The square root of 4, what if we do this? That's 3. And the square root of 4 is 2. And then on the inside, we can't take the square root of 3 times 2, or we can't take the square root of 3 or 2, I should say. We can't simplify those. So then, finally, we're left with 6 times the square root of 6. And that's our final answer. That's the area of that triangle. And before you knew Heron's formula, you would have had to maybe use some sort of law of cosines or try to find the height in a weird way. But here we can just use Heron's formula and get the area. Okay, now let's look at part B. This triangle has 3 bases and 3 heights. All the bases were given. Find the 3 heights. Well, now that we know the area, we can use our original formula for a triangle. Area is 1/2 times the base times the height. Let's go ahead and solve for height here, because that's what we're trying to find. So maybe that's an arrow. If I multiply both sides by 2 times 2 over here times 2 over here, then we have 2a equals base times height. Let's divide both sides by b. Over here, the b's cancel out. Maybe that should be orange. B's cancel out. So we're left with height is equal to twice the area divided by the base. And we have these 3 different bases. We have 5, 6, and 7. So now we can just use this new formula we found for height to get those bases. So height 1 is 2 times 6 times the square root of 6 divided by 5, which is 12 root 6 over 5, and we'll leave that there. Height 2 is, again, the top is 12 root 6 over 6, which is just 2 times the square root of 6. And height 3 is 12 square root of 6 divided by my last base, which is 7. So there's height 3. Here's height 2. Oops. Here's height 2. And there's height, well, oops. Okay, we're going with it. There's height 1. Works for me. So if you use Heron's formula to find the area of a triangle, you can easily find the heights of all the bases of the triangle.